Okay, so this is actually really similar to what we did in the first set of examples, but now we have some tools to make some of this go by a little faster. So you'll see that the first question is actually a repeat. So let's show that we get the exact same answer. The first time we did it kind of the long way. So let me write it out again. K is 1, 4, k to the third power, and I'm actually also gonna paste, I think I'm gonna, there we go. I'm gonna paste our rules just for reference. Um, so the primary one we're gonna use here, because we have this cubed, k cubed, that matches this one perfectly. Um, so we're gonna use this formula. So this becomes, instead of the n, I'm gonna write a 4 because that's the number up top. Okay, so this is gonna be 4 times 4 plus 1 over 2 all squared. And let me erase all this so we can recycle this. Okay, so all we have to do is clean this up and it should match our previous answers. So up here, this becomes a 5. Oh, I forgot my squared. And so this becomes 4 times 5 over 2 squared, which is 20 over 2 squared, 10 squared, or 100. And if you go back, that's the exact same answer that we got before, which is really good news because that means we did it right the first time. Okay, let's try the second one. So we're looking at the sum. K goes from 1 to 5, 2k plus 3. Again, let me paste our rules. Okay, so here's our rules. So this has a couple of them. I see we do have a constant multiple. That's the second one, right? We have this rule right here with the 2 and the k. But we also have some addition, right? Which will leave us with a constant multiple. So I'm going to use a couple of different rules if that's okay. I hope so. So this is going to give us sum from k is 1 to 5 of 2k. I don't really need the parenthesis, but it's fine. Plus, and notice when I split these stay exactly the same. 3. So that is using this rule right here. Splitting them up using addition and subtraction, as long as all these parts stay the same and whatever was adding or subtracting in the middle stays the same sign. I don't change my sign. Okay, and then that is going to give us, I'm actually going to move this 2 out front using this rule right here. So I'm going to have 2 outside the sigma. K goes from 1 to 5. K plus k goes from 1 to 5. 3. Could you have jumped straight from this to this? Possibly. I mean, again, it just depends on your comfort levels. So I can simplify this a little bit. So I have 2 times, and instead of k, I'm going to use, I need another color. I'm going to use this formula. So we have 2 times, and our n is equal to 5. So that 2 is still out front as a constant multiple. 5 plus 1 over 2 plus, and for, so that was for this. And then here, I'm going to use the one I already highlighted. So that's going to become, our C here is 3 and our N is 5. Again, just matching the numbers with what's there. So this becomes 5 times 3. I know because I'm dragging out the explanation, this may not actually feel faster. I promise it is once you get the hang of it and you can move through it. So this becomes 2, 5 times 6 over 2, plus 15. I'm actually going to cancel, so that 2 and that 6, that becomes a 3. So this is 2 times 15 plus 15, which is 30 plus 15, which is 45. And the idea is also that it gives you nicer numbers to work with. So the thought process is like this is a little easier to simplify than if you had to write them all out. And ours is nice because this number 5 is not a very big number. But imagine if it was like 15 or even 20. I mean, in the grand scheme of numbers, that's not that big. But that would be unpleasant, I think, to have to go through. So, okay. We have a few more of these to go through. Let's drag that down. Erase this. And I'm going to erase all of this so I can use it again instead of adding it every single time. Okay. So we are currently on number 3. So we're looking at sigma k is 1, seeing this is to 34 of 10. Does not feel like fun to have to do all that. That's a lot. So I'm going to rely on, that is a constant, which is this rule right here, which means I just multiply the two numbers. So Rn is 34 and Rc is 10. So this, according to our rule, is just 34 times 10, which anything times 10 is lovely, right? This is 340. See how quick that was? Can you imagine writing that out 34 times? Oh, that'd be awful. Okay, number 4. Let me erase this. Number 4 looks like k is 1 until 6. Notice I go from bottom to top. We'll see that notation again when we get to limits in the last chapter. 3k squared. So I am going to use this one first to move that 3 out front. And then I'm going to apply k squared, which for some reason is the ugliest of them all. There are proofs for these. I can find them for you if you're really, really interested. I figure we have enough things to learn in this class right now. So this becomes 3 times, note our n is equal to 6. So this becomes 6 times 6 plus 1, 2 times 6 plus 1 divided by 6. And that's just filling in the formula. So this 6, and this 6. This one on the bottom is just part of the formula already. However, I'm going to use that to my advantage, and I'm going to cancel those two out so I don't have a denominator anymore. So I have 3 times 7. 2 times 6 is going to be 12, plus 1 is going to be 13. Which gives me 21 times 13, 21 times 13 gives us 273. That's it. All right, I'll see you later.